Hey everyone, and welcome. If you're just starting your journey in pharmacy, you are in exactly the right place. Today, we're diving into what is, without a doubt, the single most important skill you will ever learn: pharmaceutical calculations. And look, this isn't just about getting the math right. This is the absolute bedrock of patient safety, where one tiny decimal point can change literally everything.
So here's what we've got lined up. First, we're going to talk about the why, the huge responsibility that comes with these numbers. Then, we'll get into the language of pharmacy, the systems of measurement. After that, we'll get our hands dirty crafting percentage solutions. I'll show you a fantastic shortcut called the alligation method, and we'll wrap it all up by exploring the delicate art of making solutions that are perfectly safe for the human body. So, let's jump right in.
First things first, why is this so incredibly important? Well, it's simple. Every single calculation you make has a direct line to a patient's health. We're talking about the immense responsibility behind every single prescription.
So, let me ask you a question. What do you think is a pharmacist's most critical skill? You might think it's memorizing hundreds of drug names, or maybe knowing all those complex interactions. And yeah, those are definitely crucial. But the real foundation, the thing everything else is built on, is something else entirely.
It's all about precision. Absolute, uncompromising precision. Because a patient's health, maybe even their life, is on the line. A misplaced decimal point isn't just a small mistake. It can be the difference between a dose that heals and a dose that harms. Every calculation is a direct link to a person's well-being. That's the weight of the responsibility we're talking about.
Okay, so to get that precision, we all need to be speaking the same language. And that brings us right to our second topic, the systems of measurement. The best way to think about this is like learning the grammar of pharmacy.
On this slide, you can really see the two different worlds. Over on the left, you have the old imperial system. Kind of messy, right? It's this confusing mix of grains and ounces and pounds with no real logic connecting them. But on the right, you have the elegant, simple, and beautiful metric system. It's the global standard for a reason. It's all based on units of 10. Grams, liters, and super simple prefixes like kilo or milli make everything so much more straightforward. This is the system that powers modern pharmacy.
And here's a pretty cool piece of history for you. For all you students in India, April 1st, 1964 is a huge deal. That's the day the Indian Pharmacopoeia officially adopted the metric system. It was a major step forward, a nationwide move toward modern accuracy and patient safety.
All right, so we've got our standard units down. Now let's actually use them. We're moving on to one of the most common things you'll do in a pharmacy, making percentage solutions. This is all about how we express the strength or concentration of a medicine with total clarity.
First up, and this is probably the one you're going to see the most, is weight and volume, or percent WV. It sounds technical, but it's really simple. It just tells you how many grams of a solid are dissolved in 100 milliliters of the final liquid. So a 5% WV saline solution means you've got exactly 5 grams of salt for every 100 milliliters of solution. Easy, right?
But what happens when you're mixing two liquids together, say alcohol and water? Well, that's where volume in volume, or percent V/V, comes into play. This tells you how many milliliters of one liquid are in 100 milliliters of the final mixture. It's the go-to for any liquid-in-liquid preparation.
Now, for things like ointments and creams, you can't really measure their volume easily. So for those, we use weight in weight, or percent WW. This one's super straightforward. It's just the number of grams of the active ingredient in 100 grams of the final product. Simple as that.
And finally, to complete our set, we have volume and weight, or percent V/W. You'd use this when you're mixing a liquid ingredient into a solid or semi-solid base. It just means the milliliters of a liquid you'll find in 100 grams of the final mix. Once you master these 4 types, you are ready to handle pretty much any formulation that comes your way.
Okay, let's talk about a really clever tool that you are going to use all the time. It's called the alligation method. I want you to think of it as a pharmacist's secret weapon for making perfect dilutions, every single time. This little diagram here breaks down what's often called the box method. Now, I know it might look a bit complicated at first glance, but trust me, it's genius. You just put your stronger solutions percentage in the top left corner, and the weaker one, which is often just water at 0%, in the bottom left. The concentration you want to make goes right in the middle. Then you just subtract diagonally. The numbers that pop out on the right tell you the exact parts, or ratio, you need of each. It's an awesome visual trick to prevent mistakes.
So let's put this tool to the test with a classic pharmacy problem. Let's say you need to prepare 600 milliliters of 70% alcohol, but all you have is a 95% stock solution. How do you do it?
This is exactly the kind of thing you'll be doing in the lab and in your future practice. And here's how we solve it with our box. We set it up 95% in the top left, 0% for our water in the bottom left, and our target 70% right in the middle. We subtract diagonally, and what do we get? 70 parts of the 95% alcohol and 25 parts of water. From there, it's just a simple ratio to figure out the exact volumes needed for our 600 milliliters total. It's just a beautifully logical process.
Okay, for our final section, we're going to bridge the gap between pure chemistry and human biology. This is where it gets really cool. We're talking about balancing isotonic solutions, which is all about making sure our medicines are in perfect harmony with the human body.
This table right here is your key to understanding tonicity. See, our body fluids, like our blood and our tears, have a salt concentration that's equal to 0.9% sodium chloride. That's what we call isotonic. It's in perfect balance with our cells. Now, if a solution is hypotonic or weaker, water rushes into the cells and makes them swell up. Not good. If it's hypertonic or stronger, it pulls water out of the cells, making them shrink. Also not good. The goal, always, is that perfect isotonic balance.
So how do we measure that balance with scientific precision? The answer is pretty wild. It's all about the freezing point. Our blood and tears freeze at exactly negative 0.52 degrees Celsius. That means any solution we put into the body, like eye drops or an IV fluid, has to be engineered to freeze at that exact same temperature. If it doesn't, it's going to cause stinging, pain, and can even damage cells. This number isn't just a random fact. It's our gold standard for patient safety and comfort.
So how do we hit that negative 0.52 target every single time? We use this formula. Now don't let it intimidate you. Think of it like a recipe. We start with our target, 0.52. Then we subtract A, which is the effect our drug is already having on the freezing point. The result is the gap we need to close. Then we divide that by B, which is just the power of our adjusting substance, like sodium chloride, to lower the freezing point. The final number tells us exactly how much salt to add to get to that perfect isotonic balance. This is the math that guarantees patient comfort. You know, at the end of the day, whether we're talking about tonicity or dilutions or just basic measurements, it all comes back to this one core principle. The goal is always to achieve equilibrium with the human body. Our calculations are the bridge that turns a chemical on a shelf into a safe, effective therapy for a person. So we've covered the systems, the methods, and the formulas. These are the fundamental tools of your new profession. So the final question I want to leave you with is this. Now that you have the tools and you understand the responsibility that rests on every single decimal point, how are you going to develop the focus, the habits, and the discipline to make sure every single calculation you make is perfect? Thanks for joining me.